Hey everyone, welcome to this video on PyTorch tutorial for beginners. Now this is a tutorial for anyone who wants to get started with PyTorch library. Now as you know, PyTorch is a deep learning library which we use it to build the deep learning neural network and learn the patterns in a complex data set. Now, there are two most widely used libraries. One is TensorFlow, other one is PyTorch. Now, if you want to learn the TensorFlow, check out the TensorFlow playlist, which we have already created. And if you're new to PyTorch, stay with me in this video. So let's learn the TensorFlow. Okay. So if you're new to PyTorch, so stay with me and we will understand and I'll take you through the step-by-step learning journey in this video. So the agenda of today's session is as follows. First, I'll start by helping you to install the PyTorch library. Okay, I'll show you with the easier way to install the same in the local system, and then we will start understanding the basics. Okay, first we will take up the installation, and this is followed by basics of tensors, and then we will look into the auto diff functionality, which is known as automatic differentiation functionality in PyTorch, and then we will look into the way to create the neural network. So these are the core aspects of PyTorch that everyone has to know whenever they want to think about building a neural network, and that's what we'll be covering in depth as we progress in this video. My name is Nachiket Murthy and I'll be with you in every step of the learning journey in this video. So if you have got any feedback, feel free to reach out to me on LinkedIn and I look forward to interacting with you. So thanks again, guys. So let's get started. So let's start with the first aspect, that is the installation. So how to do the installation? Well, the PyTorch team have actually made it very easy for us to get the command to install locally. So first thing is select the PyTorch build. I'm going to select the stable build that I have got right now, and my operating system is Mac OS. The package manager that I'm going to use is pip. Okay, if you want, you can also use the conda as well. And the language is Python. And the compute platform for my Mac, the only option that is available is default. So the command that I have to use it is pip3 install Torch, Torch Vision, Torch Audio. So I'll be installing all these three different libraries in my environment. Okay, before I actually run this command, I'll start by creating a new environment. So this is the official documentation page of the Anaconda. So they have mentioned that if I want to create a new virtual environment, I'll just have to start by running the command conda create -n environment name followed by the Python version. So I'm going to launch my terminal. So I'll just launch a new terminal. Now here I'll start by creating a new environment. I'm going to say conda create -n. Okay, the environment name that I'm going to call it as PyTorch. Okay, and here I'll mention the version as Python 3.9. Okay, that's the Python version that I'll be using it for the demonstration purpose. So I'm creating a new Python environment. So I'll say Y. Okay, so this is going to take care of the necessary installation. Now, once this Python environment has been created, I'm going to activate this environment by running the command conda activate PyTorch. So this will activate my new environment, that is PyTorch environment. So the base has now been changed to PyTorch. Now in the screen, I'll just copy and paste the command that I had got earlier. Okay, so we'll have to wait for some time in order for it to complete the installation. Okay, so this has been installed. So I'll start by launching my Jupyter notebook. So Jupyter space notebook. Okay, so it says command not found. So let me start by installing the same pip install notebook. Okay, this will install the Jupyter notebook for me, and then we'll be able to launch the Jupyter notebook in this virtual environment. So Jupyter space notebook. So this is going to launch a new Jupyter notebook session for me. Okay, so I've got the Jupyter notebook launched. Okay, so we can now get started and check whether we have the PyTorch library installed or not. Now to get started, okay, I'll just go ahead and create a new notebook. I'll just start a Python 3 notebook, and here I'll start by renaming a notebook. I'll start by importing a torch. So if I want to import it, we'll generally import as torch. So I'll say import torch and let's execute it. So now if this command is successful, this would confirm that we have the library installed. So in my scenario, I did not get any error, and I can also try displaying the version. So the version that is installed in my current system right now is 2.0.0. That means the installation of PyTorch library has been successful in my scenario. Okay, so now the system is ready to get started with further learning activity. So first thing that we are going to learn right now is how to create the PyTorch tensors. So when we talk about the tensors, okay, tensors are the multidimensional arrays. These are all the specialized data structure, and this is very similar to the arrays and the matrices. Now, while working with type PyTorch library, we generally make use of tensors to encode the input as well as the outputs of the model. And not just that, even when we talk about the model parameters, we'll also make use of the tensors as well. So tensors, I would say, the building blocks of working with this PyTorch library. Now, when it comes to working, these tensors are very similar to the NumPy array, except these tensors can actually run on GPU or other hardware accelerators. And in fact, the tensors and the NumPy array can often share the same underlying memory, and it also eliminates the need to copy the data. And these tensors are optimized for automatic differentiation, which you'll be seeing as we progress in our learning journey today. So let's get started, folks. So I have imported the PyTorch library, and I'll also import the NumPy library. I think I'll have to install the NumPy library. Okay, it looks like the NumPy is already present. So this removed another barrier. So I have imported the NumPy library as well. Now I'll start by creating a tensor. See, when I'm creating the tensor, just like I can initialize a NumPy array in various ways, in the same way, I can initialize a tensor with the help of torch.tensor method. So let's assume that I've got a data like 10, 20, 30, 40. Okay, so this is a list inside a list. And if I want to convert this Python list into a tensor, I'll just say x is equal to torch.tensor. That is a method that I'll be using it to convert a data into a PyTorch tensor. So if I say display type of x, see, this belongs to the type of torch.tensor. And if I display the x, see, my x has the values as 10, 20, 30, and 40. So this is of the data type tensor. So that's how I can create a tensor. And while working with this tensor object, okay, it has got the attributes very similar to what we have seen with NumPy library. So I can make use of d type, which will display the data type. So here, whenever we are creating a tensor, the data type will be automatically inferred from the given data. So in my scenario, the data type that has been inferred from this given data is the integer 64. Okay, like this, we have got other attributes as well. The other attribute that I want to introduce is a shape attribute, which we use it most of the time. So this will help us to get the shape of the tensor that we have created. And this tensor is of the shape 2, 2. See, the attributes that you see is very similar to the NumPy library's attribute, which makes it very easier for us to adjust it to work with this torch tensors. Okay, now as I mentioned, I can convert the data between NumPy array to the torch tensor in an easier manner. Well, let me just give you a demonstration about it. I'll say array is equal to np dot array, and I'll mention the data which we had created earlier. So this is going to create a NumPy array. Then I'm going to write it like this. I would say my x is equal to torch dot from underscore numpy. Okay, that's the function that we have. Now using this function, okay, we can actually create a numpy, we can actually create a tensor directly from the numpy array. Okay, so I can create the data, I can create the tensor from the numpy array. So I'll say RR. So now if I display the type of X, this will confirms that this also belongs to the torch.tensor. Okay, now just like we have got the like method that we have got in our NumPy library, we also can refer the shape from the other tensor as well. To give you an example, I'll just say, okay, so first let me just show you some of the other functions. We have got torch.once. So this is one of the function that we have that will help us to generate the torch tensor filled with ones. I'll say 4,2. So this will generate a tensor filled with the ones and the shape is 4,2. I'll say torch dot rand. Okay, so I'll say torch dot rand and I can mention my size, let's say 2,2 in this scenario. So this will fill in the values which are the random values between 0 to 1 of the mentioned shape. Okay, and I can say torch dot and I'll hit the tab key and we can get to know the various other functionalities that we have got. See, we have got as tensor, as array. So we have got various functions. So just like we have seen, you have the functions that you have in the NumPy library, we have the similar functions as well. Now I'll show you something like this. I'll say torch.once underscore like, and if I mention my data, so this is going to create an array. Okay, so this expects a tensor. Okay, I'll do one thing. I'll say x. So this time I'm saying that torch.once like x. So for x should be a tensor. So it generates the tensor filled with 1 where the shape is same as my x variable that I had created earlier. Okay, so in this way we can infer the shape from the other tensor as well. Now when we are working, okay, so as I mentioned earlier, when we start working with the torch library, that is the PyTorch library, this tensor can be actually made the computation on GPU as well. Okay, so to check where exactly this torch tensor is actually stored, I can say torch.device. Okay, so when I say torch.device, actually the x.device, so this will tell me as in which device I have actually stored this tensor x. Okay, so so this will help me to check, okay, in which device the tensor is actually present. Now the device where the tensor is placed is very important, because if I have the tensor present in multiple devices, then at that time, if I have to perform the operation between those tensors, I'll have to ensure that all those tensors are in the single device. So if I have one tensor in GPU and the other tensor in CPU, if I try to perform any operation between them, we are going to get an error. Okay, so currently, so it is present in my CPU. So let's do one thing. Let's proceed with the CPU itself. I'll make a separate video as how we can actually make use of the GPU that is present in your the M1 Mac or the processor from the Apple, where you can run the computation on GPU as well. I'll create a separate video. For now, let's focus on the basics. Okay, so we have seen about the various attributes that we have got when we start working with the tensor, and interestingly, the indexing and slicing works in the same way as you are aware of the NumPy array. So I can say x0. Okay, this will extract the 0th row, and you can perform the indexing as well, like x0, 0. You can do the indexing, you can perform the slicing, all those things we can perform on the tensors as well. Now, this PyTorch library also supports arithmetic operations on the tensors as well. So we have got various functions which will help us to perform the mathematical operation. I'll say torch.rand 2 comma 2, and I'll create one more variable, say y. Okay, and here torch.rand 2 comma 2. So I can perform the addition, I can perform the multiplication, I can perform the matrix multiplication with the help of matmul. Just like the np.matmul, we have got torch.matmul. So I'll mention the two tensors x comma y. So this will perform the matrix multiplication between two tensors, and so we can perform the division. So all those functions that we have got, straightforward function, it is available, and you can also summarize the values in the tensors as well. For example, I can say torch dot max. Okay, I can say torch dot max. So this is going to return the maximum value that I've got in the tensor x. Okay, maximum value is 0.9875 in the tensor x. Okay, and we can also specify the axis as well. So I can mention the axis. See, the concept of axis is very similar to what you are aware of in case of NumPy library. So this is about the summarization functions that we have got. Not just that, we also have torch.mean to find the mean of the data, torch.median, okay, to find the median of the data set. So these are all the various inbuilt functions that we can use it to perform the summarization on the tensors. And interestingly, we also have the reshape function as well. So I can make use of reshape function, and I can mention the tensor and specify the new shape, and I can do the reshape of my tensor to the required shape. So intuitively, it's very similar to what you are aware of in NumPy library. In most of the scenarios, instead of NP, you just have to use torch. That's all. Okay, you just use torch, you should be good, and you will be able to perform most of the activities that you are aware of from the NumPy library. So this is about the basics of working with the tensors. Now, before you move ahead, I want you to pause the video over here and just practice it and see, and you will be able to realize that how easy it is to work with this PyTorch library. Okay, so moving ahead, the next functionality that I want to show you, which I'm really excited about, is the autograd function, which is also known as the automatic gradient or the automatic differentiation functionality that we have got in PyTorch. See, autograd is a functionality which will help me to track the various operation and find the gradients in an easier manner. Okay, so when we talk about gradients, okay, so when we say gradients, it is nothing but finding the derivative. Let's say I've got a function, okay, where the function is given by f of x is equal to x squared. Now, when I say f of x is equal to x squared, okay, if I find the derivative of this f of x, so using the power rule, so this is nothing but 2 into x power 2 minus 1, which is nothing but 2x. So this is the output of this derivative of this function. Now let's say if I have the f of x is equal to x squared, okay, then if my x is equal to 5, then f of x is actually equal to 25. Now, if I want to find the derivative of my x of the function f of x when x is equal to 5, this is equal to 2x, that is nothing but 2 into 5 is equal to 10. Now, in this simple example, finding the differentiation of a function at a specific value, it is easy. But think about a very large deep learning neural network that I have. Imagine that I have got multiple layers in my neural network, and I'm interested in finding the gradient on one of the parameters of this neuron. Now, in such scenarios, okay, it is very difficult to express the gradient in terms of the value of loss function. So at that time, this functionality of automatic differentiation comes in handy for us. So whenever we are working, okay, if I want to implement the automatic gradients. So I just have to ensure that I'm tracking those functionalities. Okay, so whenever we perform the operation, we'll just say, okay, requires grad is equal to true, and post that we can call the backward function. So to indicate that, okay, we are now ready to start the computation of the gradients. So let's take up an example. So here for the demonstration of automatic differentiation, I've just written a very simple code which I've just explained earlier. So I'm defining my x as a torch.tensor, and remember, when we are calculating and tracking the gradients, we should ensure that the value inside the torch.tensor should be a floating point value. So I've mentioned as torch.tensor and mentioned this value as phi. Okay, and also in order to track the gradients, we'll also have to mention the parameter requires underscore grad is equal to true, just like I have mentioned this for the x. Now I've just squared the value of x. So when I square the value of x, obviously if you display the output of y, okay, if you display this output of y, you'll get the output as 25 because 5 into 5 is 25. Now, once I've calculated the output, okay, the next thing that I have actually done is I have called the backward method. Now, by calling this backward method, I'm saying that, okay, I have done the forward computation. That means I have completed the forward pass. Now it is time to calculate the gradients for the given data. Okay, so that is the meaning of this y dot backward. Now once I've done that, if I simply say x dot grad, this is going to return me the gradient of the y with respect to the x. So dy by dx is given by 10, which is nothing but the 2 into x, that is 10. So in this way, we can actually implement the automatic gradients, that is autograd functionality, in an easier manner. Okay, now how it will be implemented? Well, you can use this methodology, and when you are writing any model, okay, while performing the forward pass, ensuring that whatever the weights and bias term that you would define, you will say that requires underscore grad is equal to true. Okay, you can mention it in this way, both w and b, assuming that weights and bias term, and then perform forward pass. Once you perform the forward pass, so you will find the value of loss. Okay, and once you find the value of loss, then you will say loss dot backward, and then after that update the values of b and w. So while updating the values of b and w, we will say that torch dot requires no grad, so we will mention it inside that code block, and we will update the values of parameters, and we'll continue to track the gradients. So this is how we will create a training loop whenever we are working with this PyTorch library. So that's how easy it is and intuitive it is to work with this PyTorch library. Okay, so we have seen the functionality of automatic differentiation. Now lastly, what I want to show you is how we could create a neural network. So to create neural network in PyTorch, so this is the general format that we use. So whenever we are creating a neural network, we will subclass it with the nn dot module. So generally we import from torch, import torch.nn as nn. Okay, and then we are going to subclass the module which is present inside this nn. So class neural network, and this is going to get it from the nn dot module, and inside this neural network class I have defined an init method. Now inside the init method, we are going to define the individual layer structure. Okay, we are going to define the individual layer structure. What are the layers that I want? Here I'm defining my flatten layer, and I've also defined a sequential layer. So all the layer definition will be called inside the init method, and the forward pass, that means how each and every layer should be acted upon, will be mentioned inside the forward method. Okay, these are the two methods which we have to override when we are subclassing the nn dot module. Then to create a network, we'll say model is equal to neural network. Okay, that's how I would create a model. So now if I say print model, so this is going to display the overall architecture for me. Now, if I want to use this model on any data set, what I can do is I can directly send the data. Okay, I can directly send the data to my model. To give you an example, I'll say my x is equal to torch.rand. Maybe I'll have the shape as 1 comma 28 comma 28. So I have one image, and assuming that this is of the shape 28 by 28, and what I'll be doing is, okay, so here this is going to generate an output which has got 10 over here. Okay, so which is having the 10 neurons, I would say. So whatever the output that I'll get, so I'll be getting the output which is of the length 10. So I'll say my output is equal to model. I'll apply this X. So this will perform the forward pass. So if I display the shape of my output, see this is of the shape 1 comma 10. So if I want to convert it into the probability score, maybe I can say nn dot softmax. So softmax is another activation function where I can apply on top of this output. So this is how we can apply the softmax and get the predicted output. Okay, so we can define the individual layers. So all the layers are present inside this torch.nn module. So nn.flatten is a flatten layer, nn.linear is a linear operation, relu is an activation function, and below I've shown you about the softmax activation function. And here I have mentioned as nn.sequential, which is the order container of modules. So like, which is very similar to the sequential layer that we generally use it in the TensorFlow library. Okay, so most of the required models and its required functionalities are present inside this torch.nn module. And once we define the model, we can go ahead and describe the various optimization algorithm as we would prefer, and then perform the hyperparameter tuning, implement the loss function, and implement the training loop for a given data set. So that is how we would generally work with this PyTorch library. So as part of your learning journey in this video, you have understood how to install the PyTorch library, how to get started with PyTorch tensors, create a neural network, and utilize the autograd functionality. So with this, we come to the end of this video. So thank you so much guys for watching till the end. If you have got any questions, feel free to let me know in the comment section and connect with me on LinkedIn, and I look forward to seeing you in the next video.